Every electric vehicle on the road today carries a silent risk. A risk engineered into the very cells that power it. Until now. Introducing the Hybrid Power Pack, a patented dual-storage energy system from Rohera Emerging Energies. The world's first architecture that structurally eliminates thermal runaway, extends battery cycle life by up to 192%, and delivers millisecond response power, protected by 6 granted patents across India, the United States, Japan, Australia, Israel, and Eurasia. Lithium-ion cells store energy chemically. Under abuse, a sudden acceleration, a crash impact, overcharge, or extreme temperature, that chemistry becomes catastrophic. A single cell reaches 200 degrees Celsius. Oxygen is released from the positive electrode. A chain reaction ignites. Thermal runaway. The result? Fires that burn at over 1,000 degrees, that reignite hours after they appear extinguished, and that no conventional cooling system can prevent. This is not a manufacturing defect. It is a fundamental limitation of chemical energy storage. The Hybrid Power Pack solves this at the architectural level. At its core, a bank of lithium iron phosphate cells for sustained energy storage, paired with a supercapacitor bank, just 3 to 5% of total capacity in EV applications. Between them, a patented battery management system that coordinates every charge and discharge event with microsecond precision. Here is the science. Every peak current demand, acceleration, cold cranking, emergency load, is routed entirely through the supercapacitor bank. Supercapacitors store energy electrostatically. There is no chemical reaction. There is no thermal chain. Thermal runaway is physically impossible. The lithium cells never see the current spikes that destroy electrodes and trigger runaway. They operate exclusively in their optimal state of charge band, protected, stable, long-lasting.
Battery degradation is caused by 2 primary stressors: high peak currents that damage electrode structure, and heat. Specifically, the I²R heat generated when large currents flow through internal resistance. The Hybrid Power Pack eliminates both. By routing all peak current through the supercapacitor bank, the lithium cells experience a smooth, averaged load profile. I²R heat generation drops by 91%. Electrode degradation slows dramatically. The result? Validated in patent testing. 6,648 charge cycles in the Hybrid Power Pack, compared to just 652 cycles in a conventional pack. That is 192% improvement in battery life, from 3 years of service life to over 9.
Regenerative braking is one of the most powerful efficiency tools in electric vehicles, but conventional lithium cells cannot capture it efficiently. When a vehicle decelerates, the motor becomes a generator, sending a sharp burst of high current energy back into the pack. Lithium cells have limited charge acceptance at high rates. Much of that energy is wasted as heat. The electrode sees mechanical stress with every braking event. The Hybrid Power Pack supercapacitor bank accepts regenerative energy instantly, in under 20 milliseconds, no current limitation, no thermal stress. Every joule of braking energy is captured, stored in the supercapacitor bank, and delivered back on the next acceleration demand. In real-world testing, hybrid supercapacitor storage systems improve regenerative braking efficiency by 8 to 12% over conventional lithium-only packs. In a vehicle driven 40,000 kilometers per year, that translates to measurable range extension and a pack that lasts years longer.
A critical question for automotive engineers:
how much supercapacitor capacity is enough? The hybrid power pack answer? Proven through patent testing and field data, 3 to 5% of total pack capacity in EV applications. This is not a compromise. It is a precisely engineered ratio. At this proportion, the supercapacitor bank handles 100% of peak current events, absorbs all regenerative braking pulses, and maintains the lithium cells in their optimal operating window, without adding meaningful weight or cost to the overall pack. Conventional dry cells, lead-acid or nickel-cadmium, provide no peak current buffering, no regenerative braking capture, and degrade rapidly under cyclic load. The hybrid power pack replaces this limitation with a system that only gets more effective with use. 3 to 5% supercapacitor, 100% thermal safety, 192% more life.
The hybrid power pack is a patented technology granted across 6 jurisdictions: Indian Patent 301-517, U.S. Patent 10,523,019B2, Japanese Patent 6644883, Australian Patent 2015-101232, Eurasian Patent 035682, and Israeli Patent IL 256796. Designated by WIPO as novel and suitable for industrial use, certified by CIRT and DRDO. From Rohera Emerging Energies Private Limited, building the next generation of energy storage with the science to prove it. The hybrid power pack, patented, proven, ready.